Hey guys, welcome to Michelle's STEM Journey. I am Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2017, 10A, Problem 19, and it deals with permutations and combinations. I hope you all enjoy this video, and let's get started. The problem states Alice refuses to sit next to either Bob or Carla. Derek refuses to sit next to Eric. How many ways are there for the five of them to sit in a row of 5 chairs under these conditions? Okay, so because this question is a little bit complicated, we will be separating it into 2 cases. So case 1 would be when A, so Alice, sits on an edge seat. Oh, and just for clarity, Alice will be A, and then Bob will be B, Clara will be C, Derek is D, and then Eric is E. So when A sits on an edge seat, that can either mean the first seat or the last seat, which is the 5th seat. So let's first start off for when A sits on the first seat. Because A refuses to sit next to either B or C, that means that the second chair right beside A is either D or E. So let's first just put D on the second seat. That means that the third seat must be either B or C, since D cannot be next to E. So let's just put B the third chair, and then C the fourth, and then E would just fall into the 5th chair. But keep in mind that B and C can switch because their order will not matter. So this is the first scenario, when D is next to A, so when D is in the second chair. But also, don't forget, E does not have to be in the 5th chair. We just have to make sure that E is not in the 3rd chair, because D and E cannot be next to each other. That means that E can either be in the 5th chair, as we have shown right here, or it can be in the 4th chair. So when E is in the 4th chair, B and C can go next to it. And so this gives us all of the arrangements for when A is the first chair and then D is the second chair. And now let's talk about when E is in the second chair. Now that E is in the second chair, D must be either in the last chair or in the 4th chair. So when D is in the last chair, B and C would fall into the 3rd and 4th, and then, as I've said before, these two can switch because it would not matter. And then D can also be in the 4th chair, and then B and C would fall into the 3rd and last chair. So this gives us another 4 arrangements. And so this sums up the 2 scenarios for when A is in the first chair. Well, as we see right here, case 1 is when A sits on an edge seat. So we only have covered when A is in the first chair. So what about when A is in the last chair? Well, when A is in the last chair, this is actually very easy since we have already shown the cases for when A is in the first chair. Because all we have to do now when A is in the 5th chair is to just flip-flop everything. So for example, let me just take this arrangement right here. I'm just going to write it out again. So if you draw a symmetrical line, if we have a graph right here, for example, right? Then when we flip this over the y-axis, then we would get so if you see here perfectly, A is in the last chair. So basically when A is in the last chair, it is all of the other things will be the same, except it has just flip-flopped. So let me just give you another example. So let me just take, for example, this one, right? A, E, B, C, D. If you flip it, then A would automatically fall in the last chair, and then these would just go over. So now we see that when you do it this way, when you imagine it flipping over the y-axis, the combinations, the new ones when A is in the last chair, it would all still satisfy the requirements in the question. So now we see that there are the same amount of arrangements for when A is in the first chair as they're in the last chair. So when A is in the first chair right here, we have 4 from the first scenario, 4 from the second scenario, so this would give us 8. And then, as I just said, there should be the same amount of arrangements for when A is in the last chair, so there would be 8 as well. So 8 plus 8 is 16. So under case 1, when A sits on an edge seat, either the first or last chair, there's 18 possible arrangements. And now moving on to case 2, which is when A is not in an edge seat. I'm about to run out of space here, so I'm just going to erase this really quickly. Okay, so let's also just split it into scenarios. So scenario 1. There's only going to be 3 scenarios here because A can be in any seat except for the first one and the last one. So let's just start off with A being in the second seat. Well, when A is in the second seat, the 2 seats beside A must be either D or E, because keep in mind that A refuses to sit next to either B or C. So that means that these 2 seats right beside A must be D or E. And then therefore B and C can just fall in to the last 2. Well, there are a couple arrangements for this scenario because C and B can switch. And then it can also be E, A, D, B, C. Ooh. So I'm just going to name this scenario 2. So right now we have 2 arrangements from the first one, 2 arrangements from the second one. And this is all when A is in the second seat. So when A is in the third seat, that means that the 2 seats next to A must be D or E, and then B and C can fall into the rest. Of course, B and C can switch, and then E and D can switch. And when D and E switches, C and B can also switch. So this gives us 2 and then 2. And then finally, for the last scenario, or the last 2, when A is in the fourth chair, there's actually a pattern here, is that obviously, the 2 seats next to A cannot be B or C, so it must be D or E. And then BC, CB. ED, and then BC, CB. So here, we have switched DE and make that ED. And then we have also switched BC and CB. So we have covered all of the possible arrangements. So we have 2 arrangements from 1, 2 arrangements from scenario 2, 3, 4, 5, 6. Each has 2 arrangements. So that would be 2 times 6, which would give us 12. And so we have 12 arrangements for case 2. So now we can just add this up. 16 plus 12, this would give us 28. So the answer is C, 28. And also, why I chose Alice and why I gave her a fixed position is because she has the most restrictions. I mean, she cannot sit next to either B or C. So that is why I gave her the fixed position, and then I just plugged in the remaining people into the remaining chairs. But yeah, the answer is C, 28.